I'm Anil Kumar. Welcome to my series on trigonometry. I'll prove cosine law in this particular video and take up 3 questions related to solving triangles using cosine law. So let's have a triangle ABC. So here's a general sketch. Triangle ABC. And let us say the altitude of this triangle is h from C to AB. So this is perpendicular to AB. Now let the sides be, in general, will be A, B and C. And let us take A to this point altitude, let's say it is at D. A to D be x. In that case, D to B will be C minus x, correct? Now let's look into the triangle ACD. In this triangle, if I say h is the height, in that case, we can relate cosine A with x over b, right? Now from here, we can write x as b cos A. So we have one relation here which relates cosine of the angle A with the side B. Cosine law basically relates all the 3 angles with cosine of angles. That's the whole idea. So let's see the other 2 sides, how we can relate them. So now we'll explore the triangle CDB. This is also a right triangle. So we can say A square, the hypotenuse, is equal to h square plus c minus x whole square. If I expand this, I get h square plus c square minus 2cx plus x square. Rearrange. H square plus x square is b square. So I'm bringing this x together with h. We got h square plus x square. The 2c terms, c square minus 2cx. Now as you know, this is a right triangle, right? So in this triangle, sum of these 2 squares will be hypotenuse square, b square that is, right? So we could write this as b square minus, this was plus by mistake. This is plus c square. So it is b square plus c square minus 2cx. Now, in this equation, I can substitute x as b cos A, right? Now, that means from 1, we'll substitute the value of x. So in that case, what I get here is b square plus c square minus 2c, and x is b cos A. So that gives you a relation which is the side A square is equal to b square plus c square minus 2 cb cos A, right? Now this relation is called cosine law. Perfect. So we have a relation here which says a square equals to b square plus c square minus 2 bc cos A. Cos A, right? Similarly, if I draw up a perpendicular from A and then with B, I can come out with other relations. So we can rearrange this and write it as, if I'm talking about b square, then b square will be a square plus c square minus 2 ac cosine of b, and I'll rewrite this. A square equals to b square plus c square minus 2 bc cos of capital A, the angle. And similarly, we could also write this as c square equals to a square plus b square minus 2ab cos of c. Now this is called cosine law. Now it is important to note that we can rearrange this and also find the angle if we know the sides. So to rearrange, I'll bring 2bc cos A to the left side. So we could write this as 2bc cos A equals 2. We have b square plus c square minus a square. So we get cos of A equals to b square plus c square minus a square divided by 2bc. Now this is very important formula since we can now find angle. So we have derived cosine law in two ways, with two formulas. One which to find sides, one to find angle. So there are two cases where we are going to use cosine law. That is when we have SSS, all three sides, we can find angle. Or if we have side included angle and side, in that case we can find the third side. Correct? So those are the two places where cosine law will be used. In all other places we are going to use the sine law. Correct? I hope the derivation is clear. Let us try to see how to apply this formula and solve triangles. Now we have a triangle in which two sides and included angle is given. We say what is given to us is one side, angle and side. So here the angle included between the two sides is given. We need to solve this triangle. So let's label this as AB and C. Now using cosine law, we can find the side lowercase a, which is opposite to A. The formula is a square is equal to b square plus c square minus 2bc cos of A. So substituting the values, b is 12, 12 square plus 13 square minus 2 times 12 times 13 times cos of 35. So let's use calculator. What we get here is 12 square plus 13 square minus 2 times 12 times 13 times cos of 35 is equal to 57.42. So we get A as square root of 57.42. So square root of our answer is equal to 7.5778. Okay, so we can round this to, let us say, 7.6 meters. So we have the side A as equal to 7.6 meters. Now, once we know that side and we know the angle opposite to it, we can now apply the sine law, correct? To find the other angles, for example, these angles, we can now apply sine law. So let's find angle B. So we have sine of B over the side given to us, 12, equals to sine of 35 over the side which we found. We like to use 4 decimal places, 7.5778, correct, for accuracy. Now cross multiply to get the result. So we have sine of B equal to 12 over 7.5778 times sine of 35 degrees, right? So that is, let's calculate. So we have 12 divided by 7.5778 times sine of 35 degrees. It is equal to 0.9083. So to find angle B, we'll find inverse of this, sine inverse. So shift sine inverse of our answer gives us a value which is 65.27, right? Let's round it to 65 degrees. So this angle we just found as 65 degrees. So what should be the angle C? Since the sum of angles is 180, angle C will be equals to 180 degrees, take away 35, take away 65 degrees, right? So it will be 180 minus 35 minus 65, which is equal to 80 degrees. So that is 80 degrees for us. So you see how initially we have to apply the cosine law so that we get one combination of opposite angle and the side. Then we can apply the sine law to finally solve the triangle completely. But I hope that helps you to understand how to apply the cosine law. We'll take two more examples for you to practice. This time we have a triangle whose three sides are given. So that is the case of side, side, side. Let me label the triangle as ABC. And let's begin by finding an angle. So we'll begin with angle A. Now generally the formula is written as A square equals to B square plus C square minus 2BC cos of A. We can always rearrange, so we get 2BC cos of A equals to B square plus C square minus A square, and from here cos of A equals to B square plus C square minus A square divided by 2BC, right? Now we know all the sides, so we can substitute that angle and find cos, right? So we get cos of A equals to, so B square is 12 square. So when you're using this side, we are going to see here. When you're using angle A, you're going to use these two sides to add, right? So B square plus, that is 12 square plus 13 square minus the side opposite square, 10 square, divided by 2 times 12 and 13. Okay, so let's calculate. So we have 12 square plus 13 square minus 10 square equals to, divided by, within brackets, 2 times 12 times 13, bracket close, equal to 71 over 105. 104. So angle A is basically cos inverse of 71 over 104, right? So if I do cos inverse of my answer, I get 46.9, which I could round as 47 degrees, correct? So we got this angle as 47 degrees. Now once you get one of the angles, you should use sine law. Since we know this combination, right? Opposite side and angle. So now we'll use sine law and find another angle. Let's say angle B. So we can write this as sine B over side opposite is 12 equals to sine of 47 over 10. Now we can cross multiply and find the solution. So sine of B is equal to 12 over 10 times sine of 47, which is 12 divided by 10 times sine of 47 equals to 0.8776. So angle B is equals to sine inverse of 0.8776. So we'll do sine inverse of our answer, and that gives us 61.35. Correct? So, and we can round this to, let's say 61 degrees. Let's work in 61 degrees. Now what is angle C equals to? Angle C will be 180 degrees minus 47 degrees minus 61 degrees. So 180 minus 47 minus 61 gives us that answer, 72 degrees. So we get this angle as 72 degrees. So what we have done so far is applied cosine law for two conditions. One was side angle side, the other one was side side side. Now here is a test question for you. Now I would like you to pause the video, copy this question. You need to find angle P. So we are given a triangle PQR and another triangle QRT. You need to find angle P. Here is my solution. First, we are going to work with the triangle QRT. This is a right triangle. So let's work with right triangle QRT. Now here we can find QR. Since it is opposite to the angle given 55 degrees, we should use sine. Perfect. So we can write here that sine of 55 degrees is equal to side opposite, which is QR, over the hypotenuse, which is 20. So QR is equal to 20 times sine of 55 degrees. So 20 times sine of 55 degrees is 16.3830. Okay. Now we know this side is 16.3830. We'll round the answers later, but we'll use these 4 decimal places to calculate. Now in this particular triangle, we have condition of SSS. So if you see the triangle PQR, we have SSS. We know the 3 sides. To find the angle P, we should use cosine law. Perfect. So we can write a square equals to b square plus c square minus 2bc cos A formula, right? So that's the formula which we will use. Now in our case, triangle is PQR, so it's good to write in terms of PQR, correct? So now let's try to solve this question. Now this formula, you have seen how to rearrange it. So from this formula, we also know what is cos A equals to. So bringing it here, we get b square plus c square minus a square divided by 2bc. You get cos of A. So in this case, we want to find angle P. So we'll say cos of P is equal to sum of these two squares, which is 12 square plus 10 square minus this square, which is 16.4 I'm writing at present, divided by 2 times B and C, that is these two sides, right? So which is 12 and 10. So let's calculate this. So it gives us 12 square plus 10 square minus 16.4 square. We'll divide this by, within brackets, 2 times 12 times 10, which gives us minus, it is a negative one, so it gives us minus 13 over 125. Now let's find the angle P, which is cos inverse of negative 13 over 125. So we expect this angle to be greater than 90 degrees, right? Shift cos inverse of the answer, it gives you the value as 95.96. So we could say it is 96 degrees. So angle P is 96 degrees for us. Do you see how it was calculated? So remember, even if you get negative answer, it doesn't matter. The only thing is that cosine is greater than 90 degrees, right? It's an obtuse angle triangle. So I hope that helps you to understand how we can derive the formula for cosine law and use it to solve triangles, basically two types of triangles, SAS and SSS. A is included angle. Feel free to write your comments and share your views. If you like and subscribe to my videos, that would be great. Thanks for watching and all the best.